Welcome to our Winter Weather Show 2021. I'm meteorologist Tom Atkins, joined by my colleagues, meteorologists Tom DeVecchio and Craig Flint. We've got lots of cool subjects to discuss and for you to enjoy this year. I'm going to be doing the winter weather forecast for the upcoming season.
We often think of air quality as a summertime issue, but Craig Flint is going to take a look at air quality from a winter perspective.
Well, first things first, the Farmer's Almanac. We've all heard about it. Whether or not we believe it or not, that's another thing. But let's take a look at how accurate it really is. Tom DeVecchio tells us more.
The Farmer's Almanac is one of the best known publications here in the United States. It was created 16 years after we became a nation. It certainly contains a lot of useful information, but it is best known for its forecasts that it gives across the United States. As a child, I would always look forward to getting the new edition and checking out the forecast. The Farmer's Almanac claims to be 80 to 85% accurate, but is it really that accurate? Let's check things out and see what to look for to really determine the accuracy of the Farmer's Almanac. The old Farmer's Almanac doesn't explain how they come up with their 80 to 85% accuracy ratings, but we can follow some general rules to see just how accurate those forecasts are. For the most part, the more general the forecast, the more general the rules are for determining accuracy. So if you want to make your forecast as accurate as possible, the first thing you want to do is to make your forecast area as wide as possible. Next, you want your forecast to be as non-specific as possible. Really? And finally, make sure that you use as many days as you can in your forecast. The more days you use, the more accurate your forecast can be. And the Farmer's Almanac, well, it excels in all of those aspects. Here's a look at the rough aerial coverage of our forecast region, mainly Erie, Crawford, and Warren counties. And as you can see, a fairly large area for the most part. And let's say that we forecasted rain for this area. We could call the forecast accurate if the rain fell in any parts of this region. So if it rained in Corey, if it rained in Meadville, if it rained in Warren or rained in Erie, but nowhere else, we could claim that the forecast is accurate because somewhere in this area we had some rainfall. Now let's check out the actual aerial coverage from the old Farmer's Almanac. And you can see what includes Erie here. Check it out. From Syracuse through Cleveland, Detroit, Chicago, Indianapolis. This is a huge area. And the Farmer's Almanac could claim that if rain fell, let's say in Chicago, but nowhere else, they could claim that their forecast for that day was accurate because somewhere in this huge area, well, some rain fell. So they say, hey, that's pretty accurate. If I can only be so lucky. Now let's check out the specifics of the forecast and how that can affect the accuracy. So here's a look at the general forecast for November 4th through the 9th for our area. It says rain to snow. Sounds pretty general to me. When will it rain? The 4th? The 5th? When will it turn to snow? Is it light rain? Heavy rain? Will it turn to wet snow or fluffy snow? How much will accumulate? Where in this vast region will it snow? It's almost impossible not to make this forecast accurate. Of course, the other part that can make a forecast accurate, get a nice wide time frame. Here's a look at a November 2019 Farmer's Almanac forecast. Check this out. From the 14th through the 25th, periods of rain and snow. First of all, that's a pretty generic forecast, but it's 11 days. So that means that if it rained or snowed in any of those 11 days, the Farmer's Almanac could pretty much claim accuracy. So you're almost guaranteed accuracy when you add more days to the forecast period. Because all it has to do is rain or snow even once during any of those days, and the Farmer's Almanac can claim that it's an accurate forecast. Hey, I'm not here to bash on the old Farmer's Almanac. It's a great publication, enjoyable to read, and you can learn a lot by reading this book. And if you want to use the Farmer's Almanac for some general fun forecasting, go ahead and do so. But always keep a critical eye when it comes to the real accuracy of the forecasts in this book. Speaking of accuracy, just how accurate are the forecasts in the Farmer's Almanac? We're going to save that for another segment. Thanks for watching.
Thank you, Tom D. When we come back, Craig Flint will take a look at air quality from a winter weather perspective.
When you think of the air quality index, that crisp, clean winter air comes to mind. But how clean is it? Craig Flint takes a look.
Oh, great. It's going to be cloudy again. Probably rain over to snow. That's just great.
Craig, man, you're killing me with this script. You got to pick it up a little bit. Why don't you go get some fresh air?
All right, so that's exactly what I did. And it got me thinking about fresh air. We frequently talk about the air quality in the summer, but what about in the winter? How fresh is the air here in Erie? And I know just the guy to ask.
Honestly, it depends on what you're looking for. And again, I go back to in the winter, we have PM issues. In the summer, we have ozone issues. But I will say the trend-wise, air quality in Pennsylvania and generally across the eastern seaboard has gotten significantly better over the last 25, 30 years.
While we may pay more attention to the air quality in the summer months, the bottom line is there are pollutants in the air year-round to some level, but for the most part, these pollutants remain at an acceptable level. But there are some particular pollutants that Nick and his team keep an eye on.
Today, and most of the time, it really revolves around ozone and fine particulate matter. Those are really the two pollutants that we probably still have the most challenges with.
We have all heard of the term ozone, which is more problematic on those hazy, hot, humid summer days. But in the winter, it's the fine particulate matter that becomes the issue.
Where we do see challenges in the winter is in fine particulate matter, and that's the stuff that's called PM 2.5 or 2.5 microns in diameter. That's the kind of stuff that's small enough that gets past all the body's natural defenses, the hair in your nose, the mucus in your throat, and ends up residing in your lungs. We generally see that higher in the winter than we do in the summer, although on occasion we do see some summertime problems. Ozone is almost always a summertime problem.
All right, class is in session, so to the Kreger board we go. And when we talk about pollutants in the atmosphere, one of the drivers is temperature. The atmosphere extends miles and miles and miles above your head. So what we're going to do or try to do here is take that atmosphere and tilt it to get a cross section of it so we can visualize this here. So typically, the temperature decreases with height, represented by this graph here. See, there's your height, temperature cold, warm. So as you go up, that temperature is going to decrease with height. But we look for what's called a temperature inversion when it comes to trying to predict particulate matter. And what an inversion is when the temperature kind of does something funky. So with an inversion, you can see the temperature initially decreases with height, but then it increases as you go up. So when you see a trace like this, that indicates a temperature inversion. So why is that important? Let's explore. So what we're going to do is we're going to draw the Earth. Here's the surface of the Earth, okay? All right, and we'll put a little, now I was never an artist, but we'll put a little house here. Okay, and we'll put a little chimney on the house. When there's no inversion in the atmosphere, you'll see the smoke rise like that, okay? Just goes up like it normally would. So that is without an inversion. Remember that diagram I was just showing you. Now, when there is an inversion, here's what happens. And this is the way you can tell whether or not an inversion is present, and you don't even need a fancy meteorology degree. So let's put our house there again. All right, little chimney. When there's an inversion, you'll see this wood smoke kind of do this and level off, right? that indicates an inversion. That smoke hits that inversion level and it can't go any higher. So what that causes is all of that fine particulate matter to be trapped in the lower portions of the atmosphere where you and I live. So in the long run, does that mean air quality is a little worse in the winter? Yeah, but it's a small blip on the radar, and here's why.
That the air quality in the state of Pennsylvania has improved dramatically over the past 25, 30 years. We've got more work to do. Don't get me wrong, we've got more work to do, but it is much better than it was 25, 30 years ago.
So there you go. There you have it. Yeah, summer's over and the boats are out of the bay and you can't go hang out at Presque Isle on the beach. But you know what? There's still plenty that Northwest Pennsylvania has to offer in the winter months, and you can enjoy it while breathing in some of the best air you can find anywhere. I'm meteorologist Craig Flint. Back to you.
Thank you very much, Craig. Some good stuff as always. Stay tuned. Tom Atkins is back with his winter weather forecast.
Well, one of the terms you're likely going to hear thrown around a lot this year is the term bomb cyclone. You may have already heard it. What is a bomb cyclone? Well, these are extraordinary storms, and it's not like we just make up this term and throw it around willy-nilly. This is a term that has to be earned. What we refer to when we're talking about a bomb cyclone is bombogenesis. That is a strengthening area of low pressure, but there's a criteria that it has to meet. Low pressure must drop its air pressure by 24 millibars in just 24 hours for storms to be classified as a bomb cyclone. So this is not a term that we just throw around because it sounds good. It actually has a criteria. Okay, it's that time. Time to find out, what will the winter be like? Will it be cold? Probably. Will it be snowy? Yeah. But just how bad will it be? Tom Atkins crunches the numbers for us and takes a look.
Well, folks, it's that time to tackle the winter forecast. And as we know here in Erie, PA, forecasting winters can be brutal. This is a picture from the late 70s when we had huge amounts of snow here in Erie. Temperature is the other side of the winter forecast. This is from 2015, where we had the coldest February on record. Consecutive day readings of 17 below and 18 below at the Erie airport, and inland temperatures in the snow belts as low as 25 to 35 below. So it's a two-sided weather coin. We want to talk a little bit about average or normal temperatures. They're calculated in 30-year cycles every 10 years, and we'll use these to try to get an idea of how much above or below average the temperatures will be as we try to prognosticate this upcoming winter. For the past 30 years, they end, well, let's go 1991 to 2020. That's the latest cycle of average temperatures. We could also do average snowfalls. And on these 30-year cycles, you can see something very interesting. The average snowfall, and this is just for the lakeshore, the airport, has gone up steadily, slowly at first, and then more markedly later in cycles. And again, this is the latest cycle, and we now have an average snowfall for the lakeshore in Erie of 104.3 inches. So there's many methods of forecasting the winter. We have the La Nina, El Nino influence. We are in a La Nina pattern. We'll rely heavy on that. Some folks, for fun, use the woolly worms or woolly caterpillars. National Weather Service has their own algorithms, and at JET we like to take two of these analogs. In other words, finding previous La Nina winters, seeing how much snow and cold there were, and then mapping them into what we think will happen for the 21-22 winter. So the La Nina is what we call a teleconnection. It's a linkage between weather and atmospheric circulation from one part of the globe to the other. So we have to go all the way back into the Pacific. The El Nino cycle is a warming of the Pacific waters off the coast of South America, and it's been going on for hundreds of years. Peruvian fishermen noticed on certain years that their fish population swam away around December because of warming waters. So they called it El Nino, the Christ child, because it came around Christmas. The opposite pattern is what we're in right now, the La Nina, and that is the cooling of the Pacific waters. So if you take neutral in the middle, warmer temperatures at the top, and colder Pacific temperatures at the bottom, these are the La Nina years, these are the El Nino years. So what we have happened there is an irregular pattern of winds and sea surface temperatures over that eastern Pacific, and that affects the climate in the tropics. Now, first the El Nino, which we have had in years past, but we don't right now. What that generally produces is a lot of warmth in the northern United States and coolness by the Gulf. It also produces drier air in the northern United States and wetter temperatures from California, or wetter weather from California to the Gulf. But we are in the La Nina pattern right now. So what happens with the opposite is that we get cooler air, not necessarily in our region, but back towards the Pacific from the plains. And the warmth is in the southeast. Now the precipitation is generally higher in our area, and we're drier in the southeast. Well, what does that mean to us? Well, if these temperatures in the ocean are below normal, the pattern is this. We're kind of in between things as you look at this globe spin here. Here's the cool air, which doesn't always reach us, but the higher amounts of precipitation and wetness do. So you're kind of in a rock and a hard place here. Are you cold enough to tap this moisture to produce heavy snow, or are you too warm and you get a milder winter with more rain than snow? So this analog method that we're going to use is using these years in the past La Ninas, and looking for the similar weather patterns, mapping them on to what we could possibly get here. But like I said, it's really a crapshoot, because you can look at a couple La Nina winters here, 2017-18, 198 inches of snow, 95-96, 130 inches of snow. And it can go the other way. Just last winter, only 64 inches of snow, and 2011-2012, 47. So it can be very cold and snowy, or it can be very mild and less snowy. Here's our best shot as we head on into this winter. First of all, for December, we think it's going to get colder as we get into that month. 2 to 4 degrees colder on average. The snowfall, we do a wide range here, 25 to 50, because the snowfall varies from Erie to the snowbelt. So we'll say about 35 inches of snow this December in Erie, and that would be about 6 inches above normal. For January, we're going to say near average temperatures, so a little bit milder in January, with the averages in the upper 20s for temperatures, and the snowfall around 24 inches for Erie, a little bit below normal. We'll move ahead into February. A little bit milder for February, temperatures 1.5 degrees above normal, and snowfall amounts 11 to 25 inches across the area, around 14 inches for Erie. That's slightly above average. And finally, March can be a tricky month. Again, this March we're forecasting near normal temperatures, which would be an average monthly temperature around 36. Snowfall also near normal. We'll give a range of 15 to 25 and 13 inches specifically for Erie and the lakeshore. So as you look at what is usually the case here, these are the averages across the last 30 years. They can range from 101 in Erie to 105 in Ashtabula, close to 100 in Meadville, lower in Warren, and 84 inches, while the snow belt in between is 135 to 250. Well, what do we think is going to happen as we head on into this coming winter? Here are the averages of 104 versus 75, 50 to 70, 103, and 77. Those are the latest average snowfalls. Again, as we go on into 21-22, what we're looking at, or what we're suggesting, is lower than average snowfall this year because of this La Nina and its difficulty making that connection between warm, cold, and snowy and less snowy. So we'll say 85 to 95 for Erie, 65 to 75 for Meadville, 60 to 70 inches for Warren, and 60 to 70 inches for Ashtabula. That is our best guess using all those factors. Only time will tell what will happen in reality, and we'll find that out with you right here at JetFoxYourErie.com.
All right, TA. Well, we'll see how it goes. Coming up next, so much more. Stay with us.
Who doesn't enjoy making a snowman in the wintertime? And if you want to make snowman, you want to make sure you have the perfect snow. Now, most of you know that the wetter the snow, the better it packs. And generally speaking, if you want to have the best snows, you want to have what we call a ratio of 10 inches of snow to 1 inch of rain or less. That means it's a wetter type of snow, and that's when the snow can really get good packing and you can get a real good snowman. Most of the time that happens when the outside temperatures are anywhere between 26 and 32 degrees. So the forecast is calling for those kind of temperatures. Odds are pretty good that the snow will be good enough for making that perfect snowman. Forecasting winter weather is tricky at best compared to the summertime. Storms are fueled by large differences in temperature and moisture, and that's more prominent in the wintertime.
The local effects of Lake Erie and really all 5 of the Great Lakes, along with those elevation differences, only add to the challenge when it comes to forecasting snow here in Northwest Pennsylvania.
Be rest assured that your weather authority has the knowledge and experience to meet those challenges every day. We thank you for watching our show. We also want to thank our producer, Kent Urbanski, and we will be seeing you down the line, Jet Fox Your Erie, Facebook, Twitter, and everywhere else we can help you out. Have a good night.